Hello everyone, my voice is audible. Yeah, let's check. Hello, my voice is audible. Uh, my voice is audible. Okay, my dear friends, so let us start today's lecture, right? So today we are going to talk about conservation of momentum. It's a very basic principle, right? These two concepts are very important in mechanics. Okay, in this entire mechanics, these two concepts are very important. First is conservation of momentum, and second is conservation of energy. Okay, this both the concepts are very important, and you need to learn it, right? So we will just talk about this conservation of momentum. This is very small topic. Okay. After that, we'll solve some questions so that we can understand in a proper manner. Okay. So here you can see in this. Yeah. So in this diagram, you can see what one cannon is there. Okay, and it is firing a bomb, right? So what's going on? Bomb is going forward and this cannon is going backward, right? Why it happened? Because there is a blast. There is a blast inside this cannon, right? So this blast is providing an internal force, है ना, that is provided to bomb and that is provided to what, cannon also. So both are moving in opposite direction. Okay, so there is no external force, there is only and only internal force. Okay, so whenever there are only and only internal forces present in a system, there is no external force. Okay, so in that situation, momentum of the system remains conserved. Okay, momentum of the system remains conserved. Momentum of individual component may change, है ना? Means here what is going on, initially completely cannon and this bomb both are at rest, right? Just after the blast, bomb is moving and cannon is also moving, but both are moving in such a way that the total momentum of system remains constant, right? Yes. So this concept we are going to talk about today, right? So yeah, so this is the basic thing I wanted to start with, right? Because always we are starting from an academy, so today we are starting little in a little different way. Okay, so now I'm coming back to our introduction part, and after that we'll move to our topic. So I will teach you this topic in a proper manner. You will like it definitely. We have good examples, you will never forget it. Okay, so this is an interesting lecture, just you need to focus and you should have little interest. Okay, so let's move, my dear friends. At first I would like to welcome you all, my dear friends. So welcome to Unacademy. Unacademy is the India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country with quality content and great learning experience. So, let's crack NEET UG. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various reputed institutions of India. Until now, I have mentored to the thousands of aspirants of NEET and IIT JEE. And now, I am available here to help the students of the country to learn the concepts of physics for NEET UG with the best notes and best examples. So, my dear friends, I am available here to help you. Okay. So, next I will talk about our motto. We want you to crack NEET UG with the India's largest learning platform, Unacademy. So, what you need to do? You need to get the Unacademy subscription. So, on Unacademy app, you just click on this get subscription, and then you can directly move to that page, or you can get the Unacademy subscription, right? Okay, so let's move. If you did not download the Unacademy app yet, please go to Play Store and type Unacademy learning app and download it. Okay, after that you need to get the Unacademy subscription. Okay, so what you will get if you get the Unacademy subscription? So you will get the daily live classes, right? Our educators give you provide you the daily live lectures. You can chat with them, you can engage in any discussion, you can discuss your answers also. Okay, after that, live quizzes, right? So you can evaluate your performance, without evaluating your performance you cannot know how much you are learning, how many concepts you can apply properly, and how many concepts you are weak, you know. So you'll get its detailed analysis. Next I will talk about the structured courses. Or structured courses means physics, chemistry and biology. All three subjects you will get by the India's top educators. After that you can watch unlimited live and recorded courses from the India's top educators, right? Okay, and you will get the test series also. So these are the basic things I wanted to say. Next, I will talk about our free live classes, right? These are available on YouTube. You can see, and some special classes are also there on Unacademy app. Okay, so let's move, my dear friends. Our top educators are mainly from IITs, NITs, AIMS, and reputed MBBS colleges, and they have produced many good ranks. So they are very experienced, and you can enjoy with them, right? You will also get the good ranks. Okay, so next I will talk about the Unacademy subscription. You can see 1 month subscription is available for 6,000. Okay, and 12 months is for 30,000, and 24 months is available for 36,000 rupees. So this is equivalent to 6 months fee. This is equivalent to 5 month fee. And you can see 6 into 5, so 30, right? But if you use my code RAHULD, simply use this code Rahul D. Okay, you'll get the 10% instant discount, and you will get the 1 month subscription for 5,400 rupees, 12 month subscription for 27,000 rupees, and 24 month subscription for 32,400 rupees only. So my dear friends, definitely if you want to get an Academy subscription, use my code RAHULD. Okay, so I'm saying if you are giving exam in 2021, you should get the Unacademy subscription of 12 months. Okay, yeah, and giving in 2022, definitely you should prefer 24 months. Why not 1 month? Because in 1 month hardly you will learn 3 or 4 topics, right? But in 12 months or 24 months, you can cover the entire syllabus, my dear friends, and you'll get the test series also. Okay, so let's move, my dear friends. Today's topic. So our today's topic is conservation of momentum. My dear friends, conservation of momentum. You know what is the meaning of conservative? You know, conservative means which do not like the changes, right? Means this is mine, means it is mine. I cannot share with anyone, right? So no exchange. Okay, so conservative, right? Yeah. So conservation of momentum, right, means the momentum of the system remains conserved. The momentum of the system remains constant. That's all. So that is the conservation of momentum. So we'll talk about this law of conservation of momentum. Okay. So let me take the black ink. Okay. Today I will prefer black ink. Just a minute. Uh, where is the cursor? Yeah. Yes. So now I'm going to talk about the law of conservation of momentum. What is that? We know one thing. Newton's second law. Newton Dada told that F is equals to what? dp by dt. है ना? Newton's second law. All of you know what? That is what? Rate of change of momentum. That is equals to what? Force. So F is equals to dp by dt. All of you know this, right? This is the second law, right? Newton's second law. What is that? F net. Okay, and that is external force. What? External force. So that's why I'm writing here external. So that is dp by dt, means rate of change of momentum. So for a system, this thing all of you know in Newton's second law. If I will say, let's say external force is absent, external force is not present, so I will say what? dp by dt. Dp by dt is equals to 0, means momentum is a constant. So this is applicable for what? A complete system. So I will say if net external force on a system is 0, then I will say the total momentum of the system remains conserved. What is momentum? So let us talk about that. Okay. So I will say the total linear momentum of a system of a particle is equal to the product of total mass of the system and velocity. What it means? Let's say I have a mass m, okay, and its velocity is v. Okay, so let's say this is the particle of mass m. It is having velocity v. So it's just a minute. Yeah. Yes, so its momentum can be written as P is equals to m into v. Are you getting? P is equals to m into e. So it is just the product of mass and velocity of the particle, right? So this is just the momentum, okay? And we need to talk about this today, right? So I'm saying the momentum of system just mass into velocity, okay? So if I am talking about momentum of a system, so let's say I have a system, it is having more than one masses. So I will say let's say m1, m2, these all masses are there, m3, है ना? And these are moving with some velocities, different velocities, v1, v2, v3, okay, like that. So I will say momentum of the system. Momentum of the system can be written as momentum of first particle plus yeah, let me write it properly, momentum of second particle plus momentum of third particle, so on, like that. Okay, so what is that? Mass of first particle, velocity of first particle plus mass of second particle, velocity of second particle, so on, like that, right? We can write this is the momentum of the system. Okay, yes, so this is the basic thing. Okay, so if I'm saying ki this can be written as like this: total mass of the system into velocity of center of mass. Total mass of the system into velocity of center of mass can also give the total momentum of the system. Okay, so this is the basic thing. You don't need to worry about that. As we solve the question, you will get everything. Okay, so let us talk about this. F external. If external force on the system is F external, and that will be equal to rate of change of momentum of the system. This is Newton's second law. Okay, so if external force is absent, F external is zero, then I will say what? dp upon dt is also zero, and the momentum of the system remains constant, remains conserved. Okay, right? So net external, remember law of conservation of momentum is what? If the net external force on a system is zero, then the total momentum of the system remains conserved. That's all. This is the law of conservation of momentum. Okay, so when the vector sum of the external forces acting on a system is zero, then the total linear momentum of the system remains conserved. So this is only the law of conservation of momentum. Okay, this thing only I explained you. So let's talk about this. What is momentum of system? So momentum of system is what? Momentum of component of individual, momentum of individual components of the system means P1 plus P2 plus, and momentum is a vector quantity. So we will write it in a vector form. That's all. Okay. So here I can write what is this entire P system. P system, yani ki momentum of the system. That is sum of momentum of individual components of the system, and that is always constant. Okay, that's all. So this is what law of conservation of momentum. So now we'll learn its application. How to apply, sir, how to apply this type of concepts in a question. Yes. So this thing I told you. Next, I will talk about law of conservation of energy simultaneously here. Listen. So what is law of conservation of energy? Let's say initial energy will be equal to initial energy is equal to final energy. Matlab K initial plus U initial means initial kinetic energy plus initial potential energy will be equal to final kinetic energy plus final potential energy. So this is law of conservation. This is just the conservation of energy principle, and this we will use. That's why I just introduced here. I'm not explaining it. This you learn in where you learn in work, power, and energy. So let's move. Let us talk about question number one. So now we'll solve so many numericals, so many questions. Then only you'll understand this question. The question in front of you is written that a man of mass 60 kg pushes a block. Okay, so pushes a block of mass 20 kg on a frictionless surface. Okay, let's say he is pushing with just a jerk. He is giving a jerk. Okay, so let's say here is a man and here is a block, and this both are on a frictionless surface. So this man will apply force on this, means just giving a jerk. Okay, so what will happen then? This complete surface is frictionless. This surface is frictionless, so block will go in this direction, and man will slide in opposite direction. Why it is go why it is happening? Because initially this both are at rest. Okay, consider initially both are at rest, so initial momentum of the system is zero. Initial momentum of system is zero. Why? Because initially the block and man both are at rest. It is not written in the question, but I am telling you they are at rest. Initially both are at rest. Okay, now the block moves with a velocity of 18 meter per second. So velocity of block is given, that is 18 meter per second. Okay, and they are asking what is the velocity of man. Okay, so velocity of man is asked. Okay, so finally I am saying ki let's say final momentum is mass of man. Okay, so I am just writing it mass of man into velocity of man, okay, plus mass of block into velocity of block. Don't afraid of this vector sign, okay. This vector sign, it will just represent a direction, nothing else, okay. So no need to afraid of this. So I am saying right direction, rightward direction is positive and leftward direction is negative, okay. Yes. So what I will write, mass of block into velocity of block. Velocity of block is 18. So I will write here what, mass of block into velocity of block. So mass of block is given in the question. How much is that? Mass of block is 20. How much? 20 kg. So this is 20 into velocity of block. It is given 18. Okay. Mass of man, that is 60 kg. है ना? That is what, 60 kg. And velocity of man, that we need to find. So I'm just keeping it like this. And we know one thing, there is no external force in this system. Only two particles, yeah, two objects are present, one the man itself and another is block itself, right? So man is pushing the block, so man is applying force on the block and block is applying force on the man. So both are applying force on each other and that force will be internal force. What? That will be internal force. So I will say on this system of man and block there is no external force. So whenever external force is absent, so external force is zero. So I will say what, momentum of the system will remain conserved. So P is equals to constant, momentum of the system remains conserved. So directly I will say P initial will be equal to P final. Initial momentum will be equal to final momentum. So let us write, initial momentum is 0 and final momentum. Final momentum I have written here. So that is 60 into Vm vector. Vm. This vector sign just represent direction, nothing else. Okay. Yes. It is just showing the positive or negative. Okay. So automatically we will get in the answer. Okay. So here 20 into 18. That's all. So we are getting here what? Vm is equals to, just transfer this. Okay. So minus 20 into 18 divide by 60. That's all. So we are just simplified it, okay, nothing else. So we are getting the value of pm, what, this is 1 by 3, right? Yeah, and this is 6. So 6 minus 6 meter per second means the man will move with the velocity of 6 meter per second in the backward direction, leftward direction, because left direction considered as negative. So we are getting the answer minus 6 meter per second. This is the answer for this question. So I think all of you got it, right? Did you understand? Yes, yes, yes. So I hope you are getting it, right? Let us move to the next question, my dear friends. So this was the basic example I wanted to explain you. That's all. Okay. Yes. So now I will talk about the next second number question. Okay. Yeah, this is the question number two. In question number two, it is written that a shell is fired from a cannon. I know before some time you saw the cannon, right? Yes, so a shell is fired from a cannon with a speed of 100 meter per second. So it is given that the initial speed of the cannon is 100 meter per second at an angle theta is equals to given 60 degree. Okay, with the horizontal and positive x direction. Okay, now at the highest point of the trajectory, so I mean to say, let's say this is ground and from there angle theta means 60 degree, a cannon is fired, so it will go like this. Okay, and at the highest point of trajectory, what's going on? At highest point of trajectory, the shell explode into two equal fragments. Okay, one of the fragment moves, equal fragments means m by 2 m by 2, है ना? Total mass, let's say m. So half mass and half mass means two equal masses, right? So m by 2 and m by 2. Okay. So one will move with, so I am considering this is positive x direction, positive x. So this will be negative x. So one moves with the velocity of 50 meter per second in negative x direction. So what will be the speed of other fragments? Okay. So let us talk about this at maximum height. At maximum height. Okay, so I will talk about the maximum height. What is happening at the maximum height? है ना? So I will simply say at maximum height, है ना? What will be the velocity? So I will say ux, initial velocity, ux. So ux will be equal to u cos theta. All of you know, right? Component of velocity in horizontal direction for a projectile. What is the trajectory of this projectile? That is what is the trajectory of the shell? That is projectile motion. So during the projectile motion, when the particle is at the maximum height, you know, so what will be its velocity? Vertical velocity will be 0 and particle will have only and only the horizontal component, that is u cos theta. So I have written u cos 60 degree. So u cos means 100 cos 60 degree means 1 by 2. Okay, so directly I will get 50 meter per second. So I know one thing, कि just before blast है ना, just before blast the velocity of that shell is ux and that is 50 meter per second. So I will write initial momentum. What is initial momentum? So that will be equal to, I'm taking rightward direction positive, leftward direction negative. So directly I will write, let's say mass of that shell is m and its velocity is ux. Okay, so directly I will get m into 50. So this is initial momentum. Now the cannon will blast and it will divide into two fragments of equal masses. So m by 2 mass is this, m by 2 mass is this. So this will go, let's say, with velocity v2, and this is going in with v1, and it is already written in the question. Velocity is what? v1 in the negative direction. So I will write v1 is equals to minus 50. It is already given here. It will move in with 50 meter per second in the negative x direction, right? So directly I will write what? Minus 50 meter per second. And this v2 we need to find. So what I will write? Final momentum. Initial momentum we got. So final momentum will be what? Final momentum will be m by 2. Okay. Into v1. M by 2 into v1 plus m by 2 into v2. That's all. So let us put the value. Let us put the value. Will what we'll get? So minus m into 50 by 2, because minus 50 is its velocity. Okay, plus here m by 2 into v2, and v2 we need to find. So now what we'll do, we are simply saying it, there is just a blast. So blast, during the blast there is only internal force, that is because of chemical reaction. Okay, so there is no external force. So simply I will say the external force present on the system is what? Zero in horizontal direction, है ना? In horizontal direction external force is zero, so we can conserve the momentum in horizontal direction. So I will say initial momentum will be equal to final momentum. So let us write the value. Initial momentum was zero, sorry, not zero, that was what was the initial momentum? M into 50. So here I will write m into 50. Let me write it properly, just a minute. Do we have space? Okay, no. So let me write it here only, just a minute. Let me make some space here. Okay, so I think this much you understood very well. Okay, this much you understood very well. So I'm just erasing it, and now I'll talk. Okay, so ux is equals to u cos theta. So u 100 cos 60 degree, that is what? 50, है ना? So I will write initial momentum. Initial momentum is what? At maximum height. So at maximum height just before blast, so that is m into ux means 50 m. Okay, that's all. And final momentum is m by 2 into minus 50, है ना? Means m by 2 into v1 plus m by 2 into v2. So m by 2 into v2 we need. So now I am saying the external force present on the system is zero in horizontal direction. So in horizontal direction we can apply the conservation of momentum principle. So directly I will write what? Initial momentum will be equal to final momentum. Just before blast is initial and just after blast is the final. Are you getting? So momentum, we are applying the conservation of momentum principle just before the blast, just after the blast. So 0 will be equal to, not 0, sorry, 50 m, and 50 m we have written. So 50 m, sorry, 50 m is the initial momentum, right? It is written here, this one. So that will be equal to final momentum. So that is minus of m by 2 into 50, right? Plus m by 2 into v2. So we just need to find the value of v2. So let us find it. How to do it? So directly you can see what this is. Yeah, v2, all m are cancelled. This m, this m, this m cancel, right? Let us take LCM. So we'll get this is 100 and this will come this at 150. 150 meter per second. So this is positive. So I will say first fragment is moving in this direction with minus 50 meter per second velocity. The second will move in this direction with 150 meter per second velocity. Okay, that's all. So this is the solution of the question, and I think you are getting it very well, right? That's all. So this is the simple question, and I think all of you can do it. Okay, right. So Uh, let's move to the next question, my dear friends. This is question number 3. A man of mass m is standing on a platform of mass capital M. Okay, on a smooth ice. So smooth ice, on that a plank is kept, on that a man is standing. If man starts moving on the platform with speed you relative to the platform, है ना? So it is given that, yeah, let's okay, no diagram is there, so I have to make. Let's say this is a plank. Let's say this is a plank. It is placed on a frictionless surface. On that, a man is standing. So this is a man. Okay. Let's say it is given in the question. I am just considering, let's say, velocity of man. Okay, velocity of man Vm and velocity of plank Vp. So Vp will be in backward direction, obviously, because man is moving in forward direction, so plank will move in backward direction. Why? Because according to the law of conservation of momentum, one momentum is positive, so second momentum should be negative. Okay, right. So Vp will be in backward direction. So Vm we need to find, Vp we need to find. So let us consider Vp is equals to what? Minus V, backward direction, so minus V. Okay, so it is given in the question. What? Man starts moving in platform with speed u relative to platform. So velocity of man with respect to platform. Velocity of man with respect to platform, that is given u. Okay, that is equal to u. So what I will write the next? We know relative velocity. Velocity of man minus velocity of plank. That is equals to what? U. So now what will be the velocity of man? The velocity of man can be written as u plus vp. U plus vp vector. So what is the value of vp vector? Vp, if it is in backward direction, so I will write minus v. What I will write? I'll write minus v. Okay, so that we'll get just the magnitude at the end. Okay, so I will write the value u minus v. That's all. Okay, what is minus v? Minus v is the velocity of plank. Okay, that's all. Sure. So we got this much information. Now I know one thing, there is no external force, just man is walking, and because of the friction force, the uh, plank is moving in backward direction, ground is smooth. Okay, yes, so directly I will say ki just the friction force is static. Whenever a man walks on a platform, the friction force between the man and the platform is always static, then only the man will be able to move. Okay, so directly I will say man is moving in this direction, so plank will move in backward direction. So that friction force and normal force will be internal force. What? Internal force. So directly I will say there is no external force, है ना? What is system? System is man and plank. So I will say on this system external force is zero. So directly I will say what? Momentum remains conserved. So initial momentum will be equal to final momentum. Okay, initial momentum will be equal to final momentum. So it is given that man is standing on a platform, so all are at rest. Initially all are at rest, so directly I will say initial momentum is zero. Initial momentum is zero, so directly I am writing what? Zero. That will be equal to final momentum. Final momentum means mass of man, that is given small m. So small m into vm vector. Okay, plus mass of the plank, that is capital M, into vp vector. Okay, yes, that's all. So I have just applied the conservation of momentum principle. Initial momentum will be equal to final momentum, and that only I applied and I am writing here. Okay, so now what you will do, just put the value. So let us put the value. 0 is equals to, here what is m into vm. Vm, value of vm is here. What is that? U minus v. So I am writing here m into u minus v. Okay, plus capital M and vp vector. What is the value of vp? Value of vp is minus v. What? Minus v. So let us write minus v here. So directly what we are getting? M into U is equals to small m plus capital M into V. So directly I am getting the answer. What? V is equals to mu upon m plus capital M. Right? Sorry, small m plus capital M. Huh. So I got what? Velocity V. V is what? V is what? Speed of the plank. So I got the speed of plank in backward direction, that is mu upon small m plus capital M. Okay, so we got the value. Okay, now if someone asks what is the speed of man, so directly I will write what? M is equals to u minus v. So let us write the value here. So directly I will put the value, so I will get finally a mu upon m plus m. Okay, mu upon m plus m. Nothing, I did nothing, just value of v I placed here. That's all. So you will get the answer. Okay, so my dear friends, this is very simple concept, and I think all of you can do it, right? Yes, 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 yes. I think you are getting it. Okay. So, my dear friends, let's move to the next question. Okay. So next question is there in front of you. Okay, I'm giving you four options for this. Let's say a flat car of mass 20 kg, flat car of mass, this is car, okay, mass 20 kg, moves with a 30 sorry, moves with a child of mass 30 kg, so mass of the child is 30 kg, okay. And yeah, so it is given that like on the cart man is standing and this system is moving with 20 meter per second velocity, okay. Right now the surface is frictionless, and now the child jumps in the direction of motion of the car with 10 meter per second velocity with respect to car. Okay. So it is given that initial velocity of system is 20 meter per second. Okay. So initial momentum, what I will write? Initial momentum of the system, that is m plus m into u. है ना? So directly I will write u initial. So directly I will write here what? 20 plus 30 into the velocity of system, this, okay. Now final momentum. So now what's going on, the boy is jumping, okay, boy is jumping, so I will say, okay, as the boy jumps, so I will say velocity of boy with respect to ground is Vp. Velocity of boy with respect to ground is Vp, and velocity of plank with respect to ground is V. Velocity of plank with respect to ground is V. That's all. So that is in this direction only, positive direction, because plank is already moving in the right direction. So I will say what? It definitely finally velocity should also be, let us consider in rightward direction only, else answer we will get automatically, it will go right or left, we will get the answer at the end, so no need to worry about that. Okay, so let us talk about this. Okay, so I'm saying ki it is given that velocity of boy with respect to plank, that is u, okay, and that its value is given, that is 10, right? So I'm just writing u here now, and its value I will put at the last, yeah, let us put here only, okay, that is, let's say 10. Okay, so what I will get, velocity of boy minus velocity of this is car, right? So let me write it c, okay, vc. Okay, so yeah, here I am writing Vp minus Vc, that is equals to 10. Okay, let us put the value. Let us put the value. So velocity of boy, what we will write? Velocity of boy is equals to value of Vc. What is value of Vc? Vc is V. So I am just writing here V. So here I will get 10 plus Vc. Okay, means that is 10 plus V. Okay, I got the velocity of the block. So now what you can do? Simply final momentum, let's write. So final momentum is what? Mass of the car into velocity of the car plus mass of the boy into velocity of the boy. Let us put the values. So what you will get? 20, okay, into Vc plus Vc. Value of Vc is what? V. So that I am writing V. Okay. Now 30 is there and Vb. Value of Vb is this, 10 plus V. So 10 plus V. I am writing here simply, nothing else. Okay. So finally, this is final momentum. So what we can do? We know one thing, no external force. So initial momentum will be equal to final momentum. Okay. So let us write the value. So initial momentum of the system was this, 20 plus 30 into 20. So directly I can write it what? 20 plus 30 is 50 into 20,000. So 1000. So I am writing here 1000. Okay, that will be equal to final momentum. So final momentum 20 Vc. Okay, 20 V. Value of Vc is V only. So 20 V plus this is 300 plus 30 V. Okay, from here I am getting. Okay, that's all. So directly let us solve it. 20 plus 30 is 50 V. Okay, that will be equal to, what is this? So 1000 minus 300 is 700. Okay, this is cancelled and we are getting V is equals to 14 meter per second. We are getting V is equals to 14 meter per second. Are you getting? So we got the velocity of the car, है ना? Velocity of the car is 14 meter per second, and positive means rightward only. So that's all. This is the answer. Velocity of car is 14 meter per second. If someone asks what is the velocity of boy, the velocity of boy is what? This one, है ना? 10 plus V. So I am applying this. So 10 plus 14, I am getting 24 meter per second. 24 meter per second. That's all. So very simple concept, right? My dear friends, I think all of you are getting it, right? So simply we have solved nothing, right? Just very simple concept. We can apply it. Okay, that's all. So just what we need to do. Once again, I'm just giving you idea. Let's see. Let's have a quick revision. So let's say I'm saying the initial momentum that is equals to total mass of the system. So 20 plus 30 is the total mass of the system. Into the system is moving with velocity v. So that is v is 20. So I am directly saying that is what 1000. Okay, I have written. Next, final momentum. So P final. P final I can write what? Mass of the car into velocity of car plus mass of the boy into velocity of the boy. Okay. Simply we can write like this. It is given in the question. Velocity of boy with respect to car. That is given. Rightward direction I am taking positive. So it is given that is 10. Okay. How can I write it? I know the relative motion formula. VAB is equals to VA minus VB. Like that, VBC is equals to VB minus VC. Okay, so that I am getting 10. It is given in the question. Now what you will do? So let us consider the plank is moving in this direction with velocity v. Okay, plank is moving in this direction, right direction with velocity v, and child is also jumping, right? So he is moving in this direction with velocity vb. That's all. Okay, I'm just writing the value vb vector minus vc. The value of vc we can write what? V. Okay, so let us transfer it right side, so we will get v plus 10. Okay, that's all. Yeah, so put this value and we'll get the answer. So let us put in p final, so we'll write it later. Let us write here p initial is equals to p final. This total momentum of the system remains conserved. So initial momentum is 1000 and final momentum is what? 20 vc. So let us write 20, and value of vc we considered what? V. So that is v plus 30 into VB. So what is the value of VB? VB is V plus 10. So let us write it V plus 10. Okay. As you will solve it, you'll get V is equals to what? 14 meter per second. 14 meter per second. So VB what you will get? You will get 24 meter per second. That's all. This is the answer. So I have explained again, my dear friends. Right. That's all. So I'm saying the momentum conservation is really very simple concept. Just you should know, you should get the idea when to apply this concept. You can apply this concept when the net external force present on the system is zero. Directly you can apply what? Law of conservation of momentum. Okay, that's all. Yes. Okay, my dear friends. So, okay, I'll share the PDF. Okay, but Neetu, one thing I want to say, uh, there is nothing in this PDF, right? Because I am only solving the question here, right? So you just understand the question, you'll get everything. है ना? But if you want this question, and you want to solve it again at home, so definitely I'll share the PDF. At last, I will share the Telegram link. Okay. So let's move. Here I just left the page, so that is useless anyhow. Next question, my dear friends, very important question. Okay, let's see. This is question number 5. So okay, so what is the question number 5? Each of the block shown in the figure of mass 1 kg, and the rear block is yeah. So it is given that this is moving with 2 meter per second, right? So this is a block of mass 1 kg and it is moving with velocity 2 meter per second in the rightward direction, right? And there is another block which is at rest and it is attached with a spring. Okay, now what's going on? Spring constant is given 50 newton per meter. Find the maximum compression in the spring. So we need to find the maximum compression in the spring. So how you'll do it? Simply speaking, listen my dear friends, simply this block is coming. Okay, this block will come and it will compress the spring. As it will compress the spring will push this block also. So what will happen? The second block will also start moving. So both will move, and at a particular instant when the compression is maximum, both the block will move with the same velocity v. Why? Listen, simple thing here. If this backward block is moving faster, then still it will compress the spring. If front block is moving faster, means the length of the spring will increase. But if both are moving with the constant velocity, means the length of the spring will remain constant. And at that instant when the spring cannot be compressed anymore, है ना? So that will be the instant when the spring is at maximum compression, and at that instant both the block moves with the same velocity. Both the blocks move with the same velocity. All okay? Yes. So at maximum compression, at max compression, right? At maximum compression, we can write what? V1 is equals to V2 is equals to V. Both the blocks will move with the same velocity. Okay? Yes. So now how to find it? So simply speaking, the spring is the part of system. Block 1 part of system. Block 2 part of system. There is no external force. My dear friends, there is no external force. Means I will say F external is 0. है ना? So in that situation, momentum remains conserved. So initial momentum of the system will be equal to final momentum of the system. Okay, what is initial momentum? Initial momentum of the system. One block is at rest, another block is moving. So m1 u1 plus m2 u2, that will be equal to m1 v1 plus m2 v2. So this is final momentum, right? Okay, let us write the value. So first block is of 1 kg, it is moving with 2 meter per second. Second block is of 1 kg but its velocity is 0. Okay, final momentum is what? 1 kg, its velocity I don't know, just it is, I have considered it is v. I know one thing, at maximum compression both the blocks will move same velocity v. So I'm just writing here v plus m2. M2 is also 1 and that is also v, right? So finally what we are getting? We are getting this 2. You know? So 2 is equals to 2v. So we are getting the value of v is equals to 1 meter per second. Means both the blocks will move together with a velocity of 1 meter per second. With a velocity of 1 meter per second, right? Sorry, 1 meter per second. So we got the velocity at the maximum compression. Okay, that's all. But what we need to find? Find the maximum compression in the spring. So what we will do, simply speaking, spring is at relaxed state initially, finally it is at compressed state. So I will say there will be the energy conservation principle, because spring force is conservative force. So whenever conservative forces are present in the system, then initial energy of the system will be equal to final energy of the system. Okay, so what we can write here? Simply we can write initial energy of the system will be equal to final energy of the system. So kinetic energy initial plus potential energy initial will be equal to kinetic energy final plus potential energy final. Okay, so my dear friends, this is a simple law of conservation of energy. At first I have applied law of conservation of momentum, after that I am applying law of conservation of energy. So what I will get? Initial kinetic energy half initial mass into velocity square, means 1 into 2 square. Yes, so this is initial kinetic energy. Initial potential energy, spring was at relaxed state, so 0. Final kinetic energy, so half, both the blocks will have same velocity, so m1 plus m2 into v. So 1 plus 1 into v square, and value of v is 1, so into 1 square, right? And plus final potential energy, so that is half kx square. All of you know key potential energy of a spring constant k and extension or compression x is half kx square. So directly we are getting here what? 2, and this will be minus 1. So yeah, so directly we are getting what? Here we can write 2 by 2 is 1, and here 2. So this final we are getting 1, and this is what? This is 50 by 2 into x square. So the final answer is x is equals to, है ना? X is equals to, we are getting what? 1 by 25. 1 by 25. Okay, that's all. So we got the answer 1 by 25 meter. You can convert it into centimeter, right? So 1 by 25 meter, and if you write in centimeter, that is what? 100 by 25, so 4 centimeter. So 4 centimeter will be the answer for this question. Okay, sorry, this is x square na, so it will be like this. Okay, so sorry, this is 1 by 5 meter, hai na? I have just written something wrong. 1 by 5 meter, now correct. 1 by 5 meter means that is 0.2 meter, and 0.2 meter can be written as 20 centimeter. So final answer is what? 0.2 meter for this question. That's all. So simply at first I have applied law of conservation of momentum, after that I applied law of conservation of energy. Okay, so I think you understood it, right? If you did not understand, I am explaining again once for a last time. So simply it is given that 2 meter per second is this. So I will say initial momentum will be equal to final momentum, right? So directly I will write 1 into 2, that will be equal to final momentum is what? 1 into v plus 1 into V. Simply, I'll write like this. Why? Because at maximum compression, V1 will be equal to V2 and that I'm considering V. That's all. So we are getting 2V is equals to 2 and finally we are getting V is equals to 1 meter per second, right? Okay, now let us apply the law of conservation of momentum. We have applied now law of conservation of energy because we need to find what? Maximum compression. So E initial is equals to E final. So we can write kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. Okay, let us put the value. So that is half m v square. Me means 2 से move कर रहा, so it is moving with velocity 2. So I am writing 2 square. Initially spring was at relaxed state, so 0. Finally kinetic energy half into both the blocks are moving with same velocity at compression. So m1 plus m2, 1 plus 1 is 2 into v square, and value of v, we got it 1 meter per second. So let us write it 1 meter per second square plus half kx square because potential energy will be stored in the spring because it is at maximum compression. So let us solve it. We'll get what? Here you will get what? 1 because 2 square 4 by 2 is 2 and this 2 to cancel 1. So it will come this side. So we'll get 1. 1 is equals to 50 by 2 x square. So we are getting x is equals to 1 by 25. Root of 1 by 25. So answer is 1 by 5 meter. That is 0.2 meter. And we can write it 20 centimeter. This is the final answer. That's all, my dear friends. Let's move to the next. Next question is question number 6. Okay. So in this question number 6, what it is written, let's see. The figure shows two blocks of mass 5 kg and 2 kg. Two blocks are there. This is 1 and this is number 2. Okay. Now it is given that the blocks are frictionless surface and connected with a spring. So they are connected with a spring. Okay. An external kick is given to uh, gives a 40 meter per second to the heavier block. So I will say a kick is given to this and it will move with 14 meter per second of initial velocity. So its initial velocity is what? 14 meter per second. Okay. Now what will happen towards the lighter block? Hai na? Huh. So now we have to find the velocity gained by center of mass. So we know one thing. What? VCM. VCM is what? M1 V1 plus M2 V2 divide by M1 plus M2. So let us put the value and get the answer. So M1 is 5 into 14 plus M2 is 2 into 0 because it is at rest now initially just after the kick. Just after the kick 2 kg block is at rest. Divide by M1 plus M2. So I will write 5 plus 2. So directly I am getting what? 5 into 14 divided by 7, right? So answer is 10 meter per second. So velocity of center of mass is 10 meter per second. Okay. Now what I will do? Next directly I will use what? I need to find the first question we got. Answer of first question we got. Now the second question is separate velocities of the two blocks with respect to center of mass. So I know one thing, velocity of one is 14 है ना 14 meter per second. Velocity of 2 is 0 just after the kick. Just after the kick it is given in the question. Now the question is asking find v1 cm velocity of 1 with respect to center of mass. So what we can write? Velocity of 1 minus velocity of center of mass. So what I can write here? So I can write velocity of mass 1 with respect to center of mass. Let us put the value. So that is what? V1 is 14 and minus V2 is 10. Sorry, VCM is 10. So we are getting 4 meter per second. So velocity of first block with respect to center of mass is 4 meter per second. Now velocity of block 2 with respect to center of mass we need to find. So V2 cm is equals to V2 minus VCM. So what we will get? So directly we will get V2 minus VCM. So that is V2 was 0 and VCM is 10. So directly I'll get minus 10 meter per second. So with respect to center of mass, first block is moving rightward with 4 meter per second and second block is moving leftward with minus 10 meter per second with respect to center of mass. Okay. Yes. So that's all. This was a very simple question and I think all of you got it right. That's all, my dear friends. So this was very simple question and I think all of you can do it right. So let us move to the next question. Okay. So this is question number 7. Okay. A light spring. Let us read the question properly and solve it. Okay. So it is given that a block, Yeah, it is given that a light spring of spring constant K 200 Newton per meter is compressed. It is compressed initially in compressed state. Okay, between two blocks of masses 2 kg and 3 kg. Okay, my dears. So this is 2 kg, and here is a spring which is compressed state. Okay, and it is attached with a 3 kg block. Right now, what's going on? So it is given that a smooth horizontal plane. Okay, the block requires a velocities in opposite as they are released, as they will be released, right? So what will happen? They will move in opposite directions, obviously, right? All of you know, if in our general life, if you just keep a spring compressed and you just leave it, so spring will just push your both the fingers, right? So simply like that, block spring is compressed between two blocks and we have compressed it. Initially it is at rest. As we will release, both the blocks will move in opposite direction to each other, right? Okay, so now the spring loses the contact with the blocks. It means the springs are not attached; they are just like placed between two blocks. And spring is just placed between two blocks. It is not just completely stuck with the block. Okay, so what will happen? The blocks will detach with the spring. Okay, when the spring comes to natural length. Okay, if the spring was initially compressed to 20 centimeter. Okay, the value of x is given, that is 20 centimeter. We can write it 0.2 meter. What? 0.2 meter, because we need only and only SI units. Okay. Yes. So now what we can do? We can do one thing. First thing, initially system was at rest, so initial momentum of system is zero. Let's say finally this block is moving in this direction with velocity v1, and this block is moving in this direction with velocity v2. Okay, that's all right. So now what we'll do, left direction is negative and right direction is positive, I am considering. So what will happen? So final momentum is 2v1 in negative direction plus 3v2 in positive direction. So negative direction leftward, right, and positive direction is rightward. Okay, I know one thing. Spring and both the blocks together are making a system. So for this system, there is no external force. There is only internal force. Whenever external force is absent, what will happen? So I am saying simply what? If external is absent, right, no external force, so in this situation, initial momentum will be equal to final momentum. Initial momentum will be equal to final momentum. So I am just applying momentum conservation. Initial momentum will be equal to final momentum. So what is initial momentum? That is 0. What is final momentum? So minus 2v1 plus 3v2. So we are getting the relation 2v1 is equals to 3v2. So let us remember this relation for now. And what we need to find? Find the find the final speeds of block. We need to find, means we need the value of v1 and v2. So let us find it. Okay, so now initially spring is compressed, means some energy is stored in it, and finally it is released, so it is converted into kinetic energy. So directly I will say energy conservation principle, E initial will be equal to E final. This law of conservation of mechanical energy. So K initial plus U initial will be equal to E final plus U final. So what we can write? Half, sorry, initially it was at rest, system was at rest, so this is 0, but spring was compressed, so half kx square. Okay, finally half m1 v1 square plus half m2 v2 square. So this is final kinetic energy, and finally potential energy, spring will come to relaxed state, so means it is 0. Okay, now what you can do, let us put the values. So 1 by 2 value of k is given in the question, that is how much? That is 200. So let us write 200 here into x square. X value of x is also given, that is how much? That is 20 centimeter, means 0.2 meter. So I'm writing here, that is 0.2 square. Okay, that will be equal to half value of m1 and m2 we should know. So what is the value of m1? So value of m1 is 2 and value of m is 3. So value of m1 is 2. What's going on? Just a minute. Okay, so value of m1 is given here and the value of m1 is 2, right? Into v1 square, that yeah, I can find it from here. right? Here it is written 2v1 is equals to 3v2. So I am just writing here 2v1 square plus half m2. M2 means 3 kg, है ना? 3 kg into V2 square. So what we can write the value of V2? Value of V2 can be written here 2V1 by 3, right? So I'm just writing this value. So 2V1 by 3 square. Just simply we'll solve it, nothing else. So what we'll get finally from here? This by 2, by 2, by 2 cancel. Okay, let us write it. 200 into 0.04. That will be equal to 2V1 square plus what we'll get here, this is 3, this will be 9, so 1 3 will be cancelled, 4 by 3, 4 by 3 v1 square. Okay, that's all we are getting. So finally let us write it properly, this 20, yeah. So what we will write, let us simply calculate it, what we'll get here. So 6 4 10, right? This is what, 10. Are you getting what we are doing? So simply this is 3 into 2 6, 6 plus 4 10. So 10 v1 square divided by 3 we are getting here, and here what we are getting, yeah. So let us write it, 200 into 8, sorry, are you getting? This value we are getting 4 into 2 8, this 20 will be, yeah. So finally what we are getting here, that is 10. Okay, my dear friends. So that's all we are getting here, right? So I think this is correct. There is no calculation error, as I know. As per my knowledge, there should be no calculation error, right? So finally, what value we are getting? So value of V1 we are getting. Let us cancel 1, 2 here. So this will be 4. This is 5. So finally, we are getting 4 into 3 divided by 5, and this is root. So we are getting here 2 root 3 by 5. 2 root 3 by 5. So that is the value of what? V1. And what is the value of V2? So V2 is equals to what value we have written? 2V1 by 3. So 2 by 3 is there, and value of V1 I am writing. Okay. So finally I'll get here 4 by root of 15. So this is the final answer. Okay, my dear friends, so this is a simple calculation we did, nothing else. Okay, simple. At first we have applied the law of conservation of momentum, after that we have applied the law of conservation of energy. So that's all. This is a simple thing I wanted to explain. Let's move. Okay, so my dear friends, very soon I am going to bring the complete syllabus from 11th class, from starting to the end. Okay, 11th class, 12th class, entire syllabus I'll bring for you. Okay, in a sequence, in detailed lectures. Okay. So next, question number 8. So let us talk about question number 8. So in this question, what is it? It is written, a block A and B have masses of 40 kg and 60 kg respectively. So they are having masses 40 kg and 60 kg respectively. Okay, they are placed on a smooth surface and the spring is connected between them, is stretched by this. Okay, so let us consider m1 is equals to 40, m2 is given, that is 60. Okay, next, x is given 1.5, sorry, 1.5, so that is 3 by 2 meter we can write, and now 1 by 2, if you cancel this point, by 10 will be there, so we are getting 3 by 2. Okay, so my dear friends, very soon I am bringing the entire syllabus for you in a detailed lecture with proper PPT. I will share everything and you'll get the like, you'll learn everything in a proper manner, right? Here now I have taken just random topics, but very soon I will bring the entire syllabus of 11th and 12th class in a sequence way from the first topic. Okay, yes. So now what we will do, it is written there, if they are released from rest, determine the speed of the blocks at the instant the spring becomes unstretched. So my dear friends, this same question we have solved just before some time. Okay, so again we will solve it. So just I am asking you four options I am giving. Option A, let's say V1 is 4.5 meter per second and V2 is 3 meter per second. V2 is 3 meter per second. Second option, V1 is 3 meter per second and V2 is 4.5 meter per second. Option number C, V1 is 1.5 meter per second and V2 is 3 meter per second. Option D, V1 is 3 meter per second and V2 is 1.5 meter per second. So which of the following is correct? है ना? So this is the simple question in front of you. Which of the following options are correct? So here I have, yeah. So this is my complete question. What are the things are given? Value of x is given, that is 1.5 meter, 3 by 2. Okay. M1 is given, that is 40 kg. M2 is given, that is 60 kg. So I think you can do it, right? Now what we will do? Simply, whenever the spring is given and it is compressed or relaxed, means there will be energy conservation principle. Why? Because spring force is always a conservative force, and whenever conservative forces are present, we can apply the law of conservation of energy. Okay, because there is no energy loss. Okay, next, no external force is present. It is given, it is placed at smooth surface and initially system was at rest. It is written here. Okay, so initial momentum is 0. Now final momentum, let us talk about it. So finally what will happen? So I will say finally when spring comes to relaxed state, the block A is having, let's say, velocity v1 in left direction and block B is having velocity v2 in rightward direction. So I will write what? Leftward direction negative, rightward direction positive. So here I will write minus 40 v1 plus 60 v2. That's all. Okay. Yes. So we know one thing, external force is absent. So initial momentum will be equal to final momentum. Okay. So put the value 0 is equals to minus 40 v1 plus 60 v2. So directly we are getting the relation between v1 and v2. What is that? I'll just cancel it. So we are getting 2v1 is equals to 3v2. 2v1 is equals to 3v2. So from here we can get the value of v1 and v2. Okay, right? So let us write the value of v1. What we can write? 3 by 2 v2. 3 by 2 v2. Okay. Yeah. So this much information we got. We got two variables v1 and v2. Now what we need to find? We need to find the maximum compression. Determine the speeds of the block. Okay. These are there and compression is given. So let us find it. Hi, Michael Jackson. So let us talk about this. So I will say कि spring was initially compressed, so initial energy will be equal to final energy, right? Yeah, Karan. I know you are Karan, but your name you have written Michael Jackson, na? Yes. You are asking Karan, you are Karan. Initial energy will be equal to final energy. K initial plus U initial is equals to K final plus U final. Okay, my dear friends. So now what we can do? Directly let us put the value. So initially system was at rest, kinetic energy 0. Initially spring was compressed, so I will write half kx square. Finally both the blocks will move with velocity v1 and v2, so half m1 v1 square. Okay, yeah, Michael Jackson, your name is Karen. Okay, half m2 v2 square. Okay, my dear. So what will be the final energy? So final energy, spring will come to relaxed state. So whenever spring is in relaxed state, its potential energy becomes 0. Okay, so let us use this half, all, let's say this all 2 will cancel, right? Okay, chalo. So now I can write k into x square. What is the value of k? So in this question value of k is given 600, so I am writing here 600. So I will write here, sorry, yeah, so here I will write 600 into x square, that will be equal to m1 means 40 into v1 square, okay, plus m2 means 60 into v2 square. Okay, so here two variables v1 and v2, but from the law of conservation of momentum, सर क्या टॉपिक है बेटा? ये कंजर्वेशन ऑफ मोमेंटम टॉपिक चल रहा है. दिस टॉपिक इज कंजर्वेशन ऑफ मोमेंटम. ओके, so value of v1 is 3 by 2 v2. So I am just writing here 3 by 2 v2. Instead of v1, what I will write? 3 by 2 v2. So I will write here, let's say 1 0 1 0 1 0 cancel. Okay, so 60x square is equals to 4 into 3 by 2 v2 square plus, yeah, here what we will get? Here directly we will get what? v2 6 v2 square. That's all. So we'll solve it simply, है ना? So directly we'll get the answer of 15 v2 square is equals to 60x square, right? है ना? So directly we are getting this is 9, 6, 15. Yes. So finally v2 square is equals to 4x square, and value of x is given in the question. Value of x is, yeah. So finally v2 is equals to 2x. Okay. So let us put the so let us put the value 2 into value of x is given in the question. That is what? 3 by 2. It is given 1.5, right? So let us write 1.5. So what we are getting? 3. Okay. So v2 is 3 meter per second. What is the value of v1? So v1 is equals to 3 by 2. v2. Okay. So we'll get what? 3 by 2 into 3. So 9 by 2, 4.5. And so value of v1 was what? 4.5 meter per second, and value of v2 is 3 meter per second. So in these options, which one is correct? So 4.5 and 3. Option A is the correct, right? That's all. Yes, Karan, this is easy topic, definitely. Okay, you say which topic you want to study. Which topic is difficult? Which topic you want? Okay, you tell me. अगला प्रश्न, next question, my dear friends. How we will deal with this question? A shell at rest at origin. So let's say there is a shell and that is at rest at origin. Okay. Now it divides, it explodes and divides into fragments. So first fragment is of 1 kg, second fragment is of 2 kg. Okay, and they fly off with 12 meter per second and 8 meter per second along x-axis and y-axis. And mkg, the third fragment is mkg. Okay, yes. Theory of relativity. Okay, my dear, theory of relativity is not in theory of relativity. Theory of relativity is not in your syllabus, right? Theory of relativity. Okay, you want to know E is equals to mc square. Okay, someday we'll take some special lecture for that. Okay, we'll talk about that. Yeah. So here I can say what key. Let's say total mass. Total mass of this is m. So m mass is equals to 1 kg plus 2 kg plus m kg. So this is the total mass. I can write what? 3 plus m. Okay, that I have written. Now yeah, now they are saying ki first this 1 kg is having velocity of 12, and this second wala 2 kg is having 8 meter per second along x-axis and y-axis. So I will simply apply momentum of conservation. P initial is equals to P final. Okay, that's all. So initial momentum will be equal to final momentum. We'll use that. Why? Because this is explosion. There is only internal force. There is no external force. So I will use this. So initially system was at rest. So this is 0. Then after that, what will happen? So after that, the system will divide into multiple fragments, right? Okay. So 1 kg is moving with 12 meter per second in x direction. So 12 I cap plus 2 kg is moving in y direction with 8 meter per second. So 8 j cap plus m. I don't know what is its velocity, so I will write m into v vector. I know its magnitude, but I don't know directions. I will just write v vector. Okay. So finally, what I am getting here. So I am getting here mv vector, that is equal to minus of 12 I cap plus 16 j cap. Okay. But in question it is given that the third fragment is moving with speed of 40 meter per second. Its speed is given. So we can do one thing. What? Let us square both sides. Let us square both sides. Okay. So what we'll get? We'll get m square. Okay, m square v square, and value of v is given 40, so 40 square, that will be equal to what we'll get here. Here we'll get it is written that 12 and 16, so its square will be 12 square plus 16 square. Why? You all know one thing, I cap plus j cap, so under root of x square plus y square. Its square I am doing. Okay, so I will get just 12 square plus 16 square. Okay, so let us solve it. M square into 1600, that will be equal to 144 plus 16 16 256 means 400. Okay, so as we'll solve, we'll get m square is equals to 400, will cancel that 1600 four times, so 1 by 4. Okay, so I am getting m is equals to 1 by 2, and 1 by 2 means 0.5 kg is the answer. That's all, my dear friends. So 0.5 kg is the answer for this question, right? That's all. So we are getting this. You know? So what is the mass of that third fragment? So the mass of the third fragment is 0.5 kg. What I did, all of you know, right? Simple question. Okay. Just I applied law of conservation of momentum. Okay. After that, I should know how to find the magnitude of a vector, right? That's all. Question number 10. Okay. Total there are 13 or 14 questions. So we'll solve all of those. Yeah, quickly. So let us talk about question number 10. You may feel that these questions are little lengthy, but I'm saying this will clear your concepts. Okay. A block moving horizontally on a smooth surface with a speed of 20 meter per second bursts into two equal parts continuing with the same direction. If one of the fragment moves with 30 meter per second, okay, with what speed does the second part moves, and what is the fractional change in kinetic energy? So we need to find, let's say this is the one block. Okay, I am considering its mass is m, and it will burst into two equal parts, so it will be divided into two parts. So this is first, this is second. Its mass is m by 2 and its mass also m by 2. So I am considering its velocity is v1 and that is given 30. v2, second velocity is v2, that I need to find, or its velocity is given how much, 20. So I will say initial momentum will be equal to final momentum. Let us apply it quickly. M into 30, that will be equal to m by 2, m into 20, sorry, m into 20, that will be equal to m by 2 into 30 plus m by 2 into v2. That's all. So let us find it. We are getting 40 minus 30, that is equals to v2. Just I have cancelled all m and I have taken LCM and just LHS RHS, right? Okay, so we will get here 10 meter per second, right? So simply we are getting 10 meter per second. My dear Karan, good question will also come, don't worry about that. Okay. Yes. So 40 minus, yeah. So we are getting V2 is 10 meter per second. Now we need to find what is the fractional change in kinetic energy. Question is, what is fractional change in kinetic energy? So I will say fractional change means change divided by initial kinetic energy, right? This is called fractional change in kinetic energy. Delta K is change in kinetic energy and fractional change is just divided by initial. So I will write what? K final minus K initial divided by K initial. That's all. Okay. Yes. So what we can do, just write it or kya? So we'll get here final kinetic energy. What is final kinetic energy? V2 we have this and V1 we have this 30. So let us write it. Half m by 2 into 30 square, right? Plus half m by 2 into 10 square. So this is initial final kinetic energy. What is initial kinetic energy? Initial is half m into v square. So this is initial kinetic energy. Divide by initial kinetic energy, that is half m into 20 square. Got it? So just simplify it, we'll get the answer. Okay. So ये पेपर जो आप सॉल्व कर रहे हो पहले सॉल्व कर लिए थे. My dear, this is not a paper, this is just a simply a lecture. Okay. So यहाँ हम क्या करेंगे, सारे 1/2m को कैंसिल कर लेते हैं सारे. Let us cancel this all 1/2m. Okay. So finally what we are getting, 900/2 plus 100/2. Yeah, you are getting, this is 30 square is 900 and this is 100. So 1000/2, 500, right? So we are getting 500 minus of 400, minus of 400 divided by 400. Okay. So what is the final value? That is 1 by 4. We are getting 1 by 4. So fractional change in kinetic energy is 1 by 4 is the answer. Okay. My dear, these are just common questions. Okay. These are common questions, not a question paper. Okay. These are general questions to just so that the students who don't know, they can understand this. Yeah. On this channel there are very less students. I don't know why there are very less students. I don't know. Yes, question number 11. So let us talk about this. Okay. So Karan, solve this question. What answer you will get? Tell me first. value of V you need to tell. Means value of this small block with respect to ground you need to tell. Okay, I'm giving you four options, you give me the answer. Okay, so you are asking the good question, so let us talk about this. No, not only you, or other students are also there. Okay, so, my dear friends, for all of you, this question is given, right. Let's say this is a frictionless surface. So this downward is frictionless. This is also frictionless, and this is just quarter circular path. And here just the block is released. Okay. So as the block is released, block will go downward, but due to normal force, what will happen? This big block will move the leftward. So let us consider its velocity is in this direction, so that is, let's say, v1 or v2, whatever you want to consider. Let us consider that this is v1, and let us consider this v2. Let us consider this velocity is v2. Okay, so you need to find initially they are doing here. So find the velocity v of the cube when it leaves the block. So when it will leave, it will come at this position. When it will come at this position, initially m was at rest, block was at rest, finally this will move with velocity v2 in this direction. Okay, yes. So you need to find the value of v2. This v2 is with respect to ground. Okay, okay. So here this is very simple question. So let us solve. Let us solve. Uh, so I will simply say ki I can see here this is first and this is second. It is simply coming down and it will come here and it will leave the big block. Okay. Okay. Yeah. You can go, Karan. You can do whatever you want. Okay. So this is V2 and this is V1. Okay, that's all. So its mass is capital M, it's small m. So what we need to do is we just have to observe what's going on. So I am simply speaking if when this block will leave this big block, at that instant both the velocities are horizontal. This is moving rightward and this is moving leftward. Are you getting? So both the blocks are having the velocities in horizontal directions only, right? So simply I will say कि both the blocks are having horizontal velocities. Means there is no external force. If there is no external force, then we can say we can apply the law of conservation of what momentum. So finally it will come here and it will leave. So it is v2 and this will move in this direction with velocity v1. Okay, so I will apply the law of conservation of momentum because external force in horizontal direction is absent. If external force in horizontal direction is absent, means we can apply the law of conservation of momentum in horizontal direction. Initially entire system was at rest, initial momentum is 0. Finally entire system is moving with different v1 velocity with respect to ground for this big, and for this small block it is v2. So I will write what? Capital M into v1. This is negative because it is moving in leftward direction. Okay, plus small m into v2, that is in rightward, so I will write positive. So finally what I am getting here, m into v1 is equals to small m into v2. Okay, that's all. First equation I got. Next we need to find the speed of this small block, yani ki v2 we need to find. So what we will do, I will write the value of v1 here. What is that? M v2 divide by capital M. Okay, so this thing I have written. Now I know one thing. The small block is coming from the top to bottom. From top to bottom means it is falling to a height of r. It is moving down to a height of radius equal to radius. So directly I will say k initial plus u initial, law of conservation of energy, right? K final plus U final. So I am simply applying the law of conservation of energy, nothing else, my dear. So law of conservation of energy I am applying. So initial kinetic energy 0, initial potential energy mgh, h means r. That's all. Final kinetic energy half m v1 square plus half small m into v2 square. What we need to find? v2 we need to find. So let us place the value of v1 here. So directly you will get the v2. So mgr, let us multiply this to right in rightward direction, yani ki, sorry, left direction means LHS. So m is only there and value of v1 what we will write? mv2 divide by capital M square plus small m is there into v2 square. Okay, now we will solve it. Let us solve it. So if I take yeah, so what I can do here, let's say, yeah, this is capital M. Okay, this is capital M. So I'm writing here V2 square common. Okay, V2 square common. Now I'll get M plus small m square divided by capital M. I just simplified it, nothing else. That will be equal to what I'm getting here. I'm getting 2 mgr. Okay, so now let us take the small m common and cancel. So directly we'll get the value of V2 is equals to 2gr divide by 1 plus small m by capital M. That's all, and its root. So this is the final answer. That's all. This is the answer. Yes, my dear. Okay. So that's all. This is the final answer I have found, and that is root 2 gr divided by 1 plus small m by capital M. Okay. That's all. So this is the answer. What I did in the last step, I have just taken the small m common. That's all, and cancelled both sides. So how many concepts are there? Only two. First, law of conservation of momentum in horizontal direction, because there is no force, external force in horizontal direction. Next, we have applied law of conservation of energy. Okay. So let's move to the next question. Okay, just two questions are more there, right? So 500 kg boat has initial velocity. Yeah, initial speed is given. That is 10 meter per second. Okay. Now it passes under a bridge. At that instant, the 50 kg man jumps straight down. Okay. So let's say this is a boat and it is moving with initial velocity of 10 meter per second. Now a man is jumping. Okay, on it, and it's yeah. So now what will happen? So both will be one system, and now the speed will change. It will become some v. So what will say? Simply the man is jumping from top direction, so it will not affect the horizontal direction, but momentum will change. Why? Because mass of the system is changing. Mass of the system is changing. Okay. So Karan is saying this is C option. Okay, let's see. So directly I will say initial momentum will be equal to final momentum. What is initial momentum of the system? So initial mass of the system is 500 into initial velocity of system is 10. That will be equal to final. So finally I am saying ki man is jumping from top direction, upward direction. So simply speaking, there will be no change, right? So there will be no horizontal velocity of man, right? So just after jumping, he will be inside the boat, and both will move with the same velocity in horizontal direction. So directly I will say mass of the boat plus mass of the man into V. So directly I am getting the value of V, that is 5000 divided by 550. So I am getting 100 by 11 answer. 100 by 11 meter per second. So answer is A for apple. Got it? My dear Karan, answer is first 100 by 11 meter per second. Okay. Yes. So obviously this is easy question, but still we need to like have we should be little uh, like aware of this, right? Key, if someone is jumping from top direction, then what will happen? Mass is increasing. So mass will increase. So obviously the velocity of the system will change. Okay. Next. Next, so let us talk about this 13 number question. A scatter of mass m standing on ice throws a stone of mass m, okay, with a velocity v in the horizontal direction. Okay, so let's say there is a scatter and it is throwing a stone in horizontal direction with velocity v. Okay, so now what will happen? With velocity v in the horizontal direction at a distance, scatter will move back is. Okay, so we just need to find the distance moved by the scatter. Okay, so simply speaking, here, if this block, let's say sorry, mass of the man is small m and its mass is capital M. Okay, so let us solve it. Very simple question. Simply, I will say man is throwing this particle. So directly, I will say what? Key, there is conservation of momentum because he is standing at ice, means frictionless surface. There is no external force, there is just an internal force between man and the particle. So directly I will say what? Let's say man will move in this direction with velocity u, and particle is moving in this direction with velocity v. Okay, apply conservation of momentum. So what you will write? Initial momentum of the system was 0. P initial is equals to P final, right? So what will be the initial? Let me write here. Initial momentum will be equal to final momentum. Okay, initial momentum is 0. Final momentum is minus mu. Sorry, minus small m. Mass of the man is small m. Oh, sorry. Just a minute. Okay, so I will erase something and I will write again. Just a minute. Yes. Okay, so let us write it again. It is given that I have just considered mass of the man is m, velocity is u, and the negative directions I have written like this. Okay, next what you can do? So directly you will write here. Okay, so directly I will write here final momentum. Final momentum will be what? Capital M into V. So that's all I'm writing here. Okay, so directly I'm getting here M into U, that will be equal to capital M into V. First relation I got, right? This is the first relation I got. Now what we need to find, how much distance this scatter will move on the surface. So simply speaking, my dear friends, this is the scatter. Okay, its initial velocity is u in this direction. What will happen? Friction is there in opposite direction. So what is the value of friction? Friction is mu m into g. Mu m into g, right? This is the kinetic friction. So directly I will apply the work energy theorem. Work done by friction is equals to change in kinetic energy. Change in kinetic energy is k final minus k initial. Work done by friction, so minus, it will be negative obviously. So I am just considering the man will cover a distance x that we need to find. So minus of mu mg into x, you know, right? F dot s. Yeah. So F dot s is work done. So work done by friction is equals to change in kinetic energy. So final kinetic energy scatter will stop. I am just applying this work energy theorem for scatter. Okay, only for scatter. So final kinetic energy is 0 and initial kinetic energy is half mu square. Okay, just put the value and get the answer. So here I am using this value of first equation number 1. So what is the value of u? Value of u is mv divided by small m. So just write it here. Value of x we need to find, right? So minus minus cancel and value of x is, just a minute here. So here I can write what, 2 mu t. Okay, this m will be cancelled with this m. Okay, now what I will write, value of u I will put. So what is the value of u? M square v square divided by small m square. Which option is correct? You can see in which option you are getting this. M square, sorry, m squared, v square divided by, yeah. So this is the C option. That is the correct answer. Okay, so that's all, my dear friends. So, Arey Michael, yeah, my dear, correct. What's going on, huh? Yeah. क्या गलत my dear? क्या गलत? C option. Okay, your answer was galat. Okay. Yeah. So Shushma, hello. In which year you are? You are in 12th class. You are in. You will give NEET exam in 2021. Karan will give in 2021. Sushma will give in. चलो. So हम आगे बढ़ते हैं. Here I got third answer, C option, right? That is the correct answer for this question. Let's move to the next. This is the last question. Okay. I think this is the last. Yes. So two blocks of mass 3 kg and 6 kg respectively are placed on a smooth horizontal surface and they are connected by a spring constant S. Now what's going on? Initially the spring was unstretched and indicates the velocities imparted. Yeah, so velocities are given here. So it is what is the maximum extension? So simply speaking, I will use what I know at maximum extension. Listen, at maximum extension, what will happen? The relative velocity of both the blocks will become zero. Means velocity of first block will be equal to velocity of second block. So I will say at max extension, at maximum extension, V1 will be equal to V2 and I am considering that is V. Remember, if the relative velocity is 0, then we will say what, the spring is at maximum extension. That's all. So at maximum extension, relative velocity always becomes 0. So directly I will apply what, m1 u1 plus m2 u2, that will be equal to m1 v1 plus m2 v2. Now with sign we will put it here. Okay, so let us write it with sign. M1 is 3 kg and its velocity is -1, plus m2 is 6 kg and its velocity is 2. This is 3 kg, its velocity we need to find, है ना? We need to find. So let us write that is v. Okay, this we have considered v, and this is m2. M2 is what, 6 kg and its velocity is also v. So I am getting here what, 6 into 2, 12. 12 minus 3, 9. 9 is equals to 9v. So value of v is 1 meter per second. So finally I will say at maximum extension, speeds of both the blocks will be same, and that will be 1 meter per second. What next? Next we need to find what? We need to find the extension, right? We need to find the maximum extension. So what you will do, directly we'll use energy conservation principle. So k initial plus u initial will be equal to k final plus u final. Okay, so let us apply this. K initial is half m1 v1 square plus half m2 v2 square. Okay, that will be equal to final kinetic energy half m1 plus m2, that is 9, right, into v square, so that is what, 1 square, and finally it will be at maximum extension. So half value of k is 200 into x square. That's all, my dear friends. So now what you will do, just cancel this 1 by 2, 1 by 2, 1 by 2. So this and this are cancelled. So simple calculation, 3 into this is what, 24, 27, 27 minus 9. So 18, 18 is equals to 200 x square. Okay, so this is 9 by 100, you know? So x is equals to root of 9 by 100. We are getting 0.3 meter. My dear friends, we are getting 0.3 meter. So that is the maximum extension of the spring. That's all. This is the answer. So yeah. Okay, my dear friends, so that's all. It was sufficient for today. So I just solved some explained some basic questions based on law of conservation of momentum. Okay, so if you want to get the Unacademy subscription, please use my code Rahul D, RAHULD. याद रखो ये code. Remember this code and apply it. Okay, and if you are giving exam in 2021, you get the subscription of 1 year, means that is for 27,000 rupees. Using my code you will just get it for 27,000 rupees, or for 2 year courses you will get it for what, 32,400 rupees. Okay, my dear friend. So yeah, it's very cheaper than any other coaching institute, uh, any other platform. So definitely for this much less amount you are getting the entire syllabus and all three subjects, entire course you are getting, right? So definitely it is beneficial. You are getting test series also, and you will have live interaction and so many facilities you will get. So definitely you'll get the top educators of the country also, right? So I will say you can perform best if you are really serious about your studies, and you are ready to hold our hand. So use my code Rahul D and hold our hand and get the 10% discount on subscription fee. So please subscribe our channel and click the bell icon. Bye bye, thank you very much. This is sufficient for today. Okay, so Sahil, our lecture is over for today, right? Let's bye bye. Good night, all.